Hi, everyone. Good morning. Welcome to day 2 of the Data and AI Summit. So this is an extremely powerful session on leveraging Databricks Unity Catalog for enhanced data governance at Unipol. Leading this session are Ben and Joe. So hope you guys have a great session. And with this, happy to welcome Ben and Joe to talk about their journey with Unity Catalog.
Thank you. Thank you. Hi, everybody, and thank you for joining us today. We are going to show you how we are leveraging Databricks Unity Catalog for enhanced data governance in Unipol. Managing data at scale at Unipol, it's more than just volume, because it means to deal with the complexity of a multi-company group. Now, let's have a look at the agenda of the day. We will start with the background about our company, and then we will show you key challenges in data governance in the insurance sector. Then we will have a look at our solution, which is based on Databricks Unity Catalog. In the end, we will have a look at how we manage data the infrastructure at scale with Terraform automation. And we will have just some final consideration about key outcomes and lessons learned throughout our journey. I am Beniamino Del Pizzo, Data Platform Manager at Unipol, and with me is Giovanni Cinquepalmi. It's a Senior Data Engineer at Data Reply Italy. So, Unipol is an Italian insurance company, and we ranked first in Italy in reputation, in non-life insurance, and in sales network. But among all that, we are the European leader in telematics, with the highest number of connected vehicles on the road. The structure of our group reflects our organization. So at our core, we are an insurance company with a lot of different companies with different business. We are evolving our ecosystems into 3 key ecosystems that are mobility, welfare, and property, in order to provide customers with value-added services throughout the everyday life. Recently, Unipol has introduced a new strategic framework, which substantially evolves around 4 strategic guidelines: stronger industrial profitability, faster integrated offering model, distribution network, better tech and people skills. Among all the assets that Unipol is exploiting to evolve our business, data and analytics plays a key role to reach our strategic goals. But what it means to deal with data at Unipol? Let's have just a quick snapshot. With us on this project, we have been Data Reply, which is an Italian consulting company focused on data solutions. Data Reply has been a fundamental partner on this experience. Now, let's have a look at data governance challenges in the insurance sector. When data lacks governance, order is just an illusion. And that's why data governance is a key factor to manage data at scale. We group data governance challenges in 3 main categories: data management, governance and compliance, and trust and innovation. With data management, it's clearly important in our scenario, the integration of a lot of different data sources that came from a lot of different companies. And then we will have a look at what this means. About governance and compliance, you have to take into account that we are a strong regulated field, and trust and innovation that go hand in hand, because strong data governance is at the foundation for enabling us to manage models and AI application effectively. Bad data governance doesn't just cause errors. It can lead to significant consequences. We are a regulated field, so we can get financial penalties if we are not compliant. And bad data can cause us to take poor decision making, because data is essential for a data-driven company, or at least for what we want to try to be. This can cause loss of trust and reputation, and worst of all, it can cause operational inefficiencies. So you maybe can have the case where you have to put data in the right place, and it's difficult without a clear governance framework. Now let's have a look at our solution. To support data governance at scale across a multi-company group, we are substantially acting on 3 different levels. Organization, a new data platform with data mesh principles in mind, and we are modernizing our infrastructure by moving to a cloud-based platform with Databricks and AWS. Let's have a look at what organizations means. Traditionally, our company has been organized with a clear distinction between business area and IT department, with the data team falling in the latter. We are now starting to follow team topologies principles. So we have introduced a cloud platform team, which is responsible to manage the infrastructure of the company. And then we have introduced, we are reshaping the data team, which is now composed by a data platform team, which is responsible to manage the data infrastructure, and it gives a standard and best practice within the data platform. We have organized several different delivery teams, which are organized in domain that trying to reflect the business organization of our company. And in the end, we have a data governance team, which is horizontal respect to the other teams, to the delivery teams. And it's responsible to manage the data product portfolio. This is because we are trying to follow some principles of the data mesh. It's not easy for us because we came from a very different kind of organization. So we are designing a new data platform, starting from a new logical architecture, because as I already told, we are trying to adopt some mesh principles. So since we have a lot of different use cases and different scenarios, we have defined the new logical architecture, which is composed by 3 different subsystems. We have the enterprise data lake, that is the subsystem where we ingest data within the data platform. So it's just for ingestion, and it's where we store source-aligned data product. Then we have the analytical platform, which is composed by 2 furthermore subsystems, the data warehouse and the advanced analytics platform. The data warehouse is just for standard business intelligence, while the advanced analytics platform is for machine learning and artificial intelligence application. In those subsystems, we store both aggregated or consumer-oriented data product. Then we have the operational platform, and it's the part of our architecture where we are able to process streaming data, and in that kind of application, the data platform itself became an operational system. So we provide other systems of the company with data that are consumer-oriented data product. We have defined a central data platform team, which is composed by a product owner, that in the end will be me, data architect, platform engineer, and administrator. So we are trying to follow mesh principles. And even the data platform itself, for us, is a product. So the data platform team is responsible to deploy platform artifact That is a self-service platform that in the company can be used by our streamlined team to realize the data product. The evolution and life cycle of this platform is guided by a federated governance community. This is a virtual team composed by different experts spread across our company. This team goes directly to feed the product backlog of the data platform team. We apply this model to each company of the group. So the data platform team and the federated governance community are entities that live within the parent company, that is Unipol. Other companies of the group can use our platform. Let's say that we release a version of the platform that is 1.0. In this slide, we see that Company X is running its platform, and it's provided with its own team of platform administrators. In reality, smaller company can exploit the administrator of the parent company through a self-augmentation model. When a company is using the platform, can ask for a new feature or can find a bug during their application development. In that case, that request goes directly to the product backlog of the platform team. Then the data platform team release a new version of the platform, and that can be used by the company that has asked for that new feature. It's important to see that not all company must use the same version of the platform at the same time. So we, as I already told, we treat the platform as a product. Now let's have a look at how we are deploying the data platform with Databricks on AWS. Essentially, we have three different environments. Each environment corresponds to an AWS account. So the development account, integration test account, and production account. Then we have a fourth account, that is the management account, and it's where we have the Databricks subscription and the Databricks account. We manage environments with Databricks at workspace level. So each workspace can use resources of a related AWS account. We have put in this slide just some AWS services. It's not an exhaustive list, but it's just to give an idea that resources live within AWS, while in each workspace we have all the kind of the Databricks objects. We deploy with the same model, the same platform for each company. This is quite effective because in this way we are able to allow companies to work in a coherent way, in accord to the standard that the central team is giving to them. And in this way, we are also able to manage costs effectively. So each company has its own accounts, and we can track costs at the level company, but even at the workspace level. So each company has its dedicated and own accounts. Now we have a look at the infrastructure of the workspace. We have essentially one workspace for each team and for each environment. Within the workspace, we have all Databricks objects, such as compute clusters, catalog, notebook, and Git integration. So we provide each team with a Git integration in order to version their code. For a data perspective, in the AWS account, we have three different kinds of buckets that are the workspace root bucket, that is to deploy the workspace, so it's really a technical bucket. We have the landing bucket to store incoming data, and the data bucket, that is where we put the real data. Then we use KMS service to encrypt the data within the data bucket, and we provide each team with the possibility to use the AWS transfer family protocol in order to send or receive data within the platform. Now we are going more into details to see the data storage architecture and the bucket layout. So the landing bucket temporarily stores incoming data. It's just a temporary area to store data. But when we start to ingest data, we put it in the data bucket, which follows the medallion architecture. We have the classical medallion architecture, but for each layer of the medallion architecture, we have different zones. Starting from the data lake, we can see that within the bronze layer, we have the raw zone that is for raw data, and conformed zone, that is a zone where we just do data typization. Then we have the silver layer, and it's where we put where we have the standard zone that is just for enhanced quality check, and the refined zone that is where we store source-aligned data product. So in the refined layer, you just have data modeled near to the source. For the data warehouse, we have just one zone for the silver layer, that is the source layer, the source zone. That is a logical layer composed by a lot of views, because we ingest data within the data lake, and in the data warehouse, we just read the data from the data lake between these views. Then the golden layer have the core market presentation zones that are just for classic business intelligence. Then the analytics platform has another different perspective, because even in this case, we ingest data ever in the data lake, but we have a golden layer composed by 3 different zones. The first one is the preprocess layer, that's for data preparation, and the registry zone is where we train and score our models, and the result zone to store the output. Then the operational platform, we have just the application zone. That is a layer that we use to serve other systems or other applications. All those architecture is within the data bucket. We have one bucket for each team. So if you remember the previous slide, and we name the bucket with the name of the team that owns the bucket itself. Then all the zones are just paths within the bucket. Now I leave you with Giovanni, which is going to show you the Unity Catalog solution.
Thank you, Beniamino. And now let's dive into what is truly become the foundation of our governance model, Unity Catalog. Govern once, enforce everywhere. This is the promise. But how do we make it real in a complex organization like Unipol? This is where Unity Catalog comes into play. Unity Catalog has been a real game changer for us, but let's take a step back. What is it really? Unity Catalog is the Databricks unified governance solution for managing any AI and data access across workspaces and teams. Unity Catalogs provide a single point of control to manage every Databricks access like notebook, AI model, and dashboard. It brings together 3 main key aspects. Centralized governance model, fine-grained access control, and audibility, all strictly integrated inside the platform. Let's see now the object model of Unity Catalog. At the core, we have the metastore, the central governance layer of Unity Catalog. The metastore is what make us possible to apply centralized governance policies across all the workspaces and environments. It also maintains all the metadata about the data, like their location, their access, and even their lineage. is also exposed at three-level namespaces composed by catalog, schemas, and the object themselves. On the top, we have the catalogs along with other secureable objects, and is on the top level when we want to organize data inside the platform. Every catalog contains schemas where they can be seen as a logical container for grouping related data assets. And on the bottom, we have the object, like tables, views, volumes, function. And this is the object the user interacts with directly. Now that we know what this is the Unity catalog, let's see how we have organized catalogs inside the platform. We have two kinds of catalogs, private catalog and shared catalogs. Each team works on its own private catalog. This is an isolated place where they can develop, explore, and even try without any concern to affecting others. When they are ready to share the data, they publish them on the data platform catalog, a place where users are usually read data in a read mode only, and this is act as the official trusted source of data. Also, the platform catalogs are organized by subsystem, and on the bottom we can see the naming convention we are adopting for private catalog. Here we can see information like company, team, and environment. This is help us to scale our platform inside Unipol. Let's see this slide again. Beniamino has already walked you through the different layers of the platform and how they support the data lifecycle. Now I want to show you this slide from a different point of view. I want to show you how we have organized catalogs and schema to represent the data architecture. Let's start from the data lake. Here we have the bronze and silver layer. Inside the bronze layer, we have a shared catalog that is focused on ingestions. And here we can see that we have schemas that are organized by source company and source systems. On the silver layer, is where we are starting aligning to the logic business. And here we can see that we have a more granular organization of the catalogs. Here we can see that we have a catalog for every domain. And on the refined zone, we also have a schema for every data product. Now let's talk about the data warehouse subsystem, where we manage data for traditional BI. Here we have the silver and gold layer. On the silver layer, we have a unique catalog that is also shared with the gold layer, and data are organized by data product. Now let's shift our focus to the analytical and operational layer. Here we are in the gold area, and here we can see that we have a catalog for the analytics layer and a catalog for the operational layer. Now let's see how we are organized the data inside the data access inside the platform. We are using Azure Entra ID as identity provider, and the groups are synchronized inside the platform via a SHIM API. In the platform, we have three kinds of accounts. On the top, we have the Databricks account that are used to manage the platform. Here we can see the different roles. We have the account admin and metastore admin that are the roles that are used to manage the platform. Also, we have an architect role that have access in a read mode on all the platform, and also an operational role that, that is focused on the maintenance. After, for every workspace, we have dedicated roles that are workspace admin, that is the account, a role dedicated for the management of the workspace. We also have the developer account role that is focused on the development of the code, and the deployer role that is focused on the CI/CD operations. And for analysts that want to interact with the data product, we also have a dedicated role. In this way, they can read and interact with the product. Let's see now how we have organized the data access inside the company. Here we can see an example where we have two different companies. On the company X, we have a typical team, team 1, that has a full access on the developer and seat workspaces, and a limited access to the production workspace. Also, when we see the catalogs in the bottom, we can see that these teams has read-write access to data on the dev and seat environment, and only a read access to the production data. On the right, we can see that there is another company with their data and their catalogs, and these data are physically separated from the other company. So the team 1 in the company X is not able to read and interact with that data. But what if they want to interact with this data? This is where data sharing comes into play. With data sharing, that is an open protocol supported by Databricks, you can interact to data that are available in another Databricks account. And you can interact with this data without copying data or duplicate them, and using the governance of Unity Catalog. But if we want to interact with data that are outside the Databricks, we can use Lakehouse Federation. Lakehouse Federation is a service that makes us possible to interact with data that are outside the platform using the tools that we already know inside the Databricks platform. This is helpful for us because this can help us to interact with data that are on the on-premise platform during the migration, but also when we want to explore data in other systems, and when we don't know if we want to ingest or not this data. Now we have seen how the governance works, also the data access and the data sharing. But now let's see how we have automated everything by Terraform. So build, apply, repeat. So we want to know how we have automated everything. Let's see how we are managing the infrastructure and scale inside the Unipol. Here we can see that we have two different cloud platforms with different service catalog, And on the right, we can see the cloud platform service catalog, where we expose low-level modules, such as network module, storage module, and so on. On the left, we can see that there is another service catalog, the data platform, that exposes higher-level modules for Databricks, like catalogs, workspace, and so on, that internally interact with the second service catalog for the services. So when a team needs a new service inside the platform, they don't need to do it programmatically or manually, but they can simply interact with the internal developer portal, and the portal is going to interact with the internal service catalogs and provide the component to the team 1. And now, back to Beniamino for the final thoughts.
Thank you, Giovanni. Now let's have our final consideration. Unity Catalog enabled us to govern data scale without slowing down innovation. Unity Catalog has been really a game changer for us. We have reached a very effective model with centralized governance, and we also can guarantee enhanced collaboration among different teams spread across different companies without slowing down innovation. We have fine-grained permission. We have an unified access layer that it's really important to manage all data spread across the organization. And essentially, it's quite important because I remember that we are a regulated field. With Unity Catalog, we can have built-in audit and lineage, so we are able to track data and its flows, and how it flows. But what have we learned throughout this journey? We have some key considerations that we want to share with you today. And we start from governance first, because often data governance is considered just a constraint, but governance brings clarity, compliance, and alignment. So it's important to deal with data governance from the first moment when you start to build something new, such as a data platform. Clear team boundaries. We are adopting team topologies approach, but it's really important to define clear responsibility among different teams. We have streamlined team, platform, even two kinds of platform teams. So the responsibility and the zone of action for each team, it's important to reduce friction and accelerate collaboration. Use an iterative approach. Don't aim to think for the first moment to reach out to the best solution, but listen to feedbacks. Work strictly with people that actually use the platform and follow their suggestions, because we have experimented that designing it iteratively to evolve the solution is more effectively. Think about scalability from the start. That it's quite simple to say, but it's important to remember, because long-term success starts with scalable design. It's difficult to scale a solution that was not think in that way from the first moment. So when you have to take some decision, it's important to think at how this will affect in the future when the platform will grow. Last but not least, tech alone isn't enough. At this point, it's at my heart, because organization and process are key factor of success. So Unity Catalog has been really a powerful tool for us. It allowed us to reach all our goals from a technical point of view, but organization, in my idea, comes first, because without a clear organization, it's difficult to design a solution that will be effective. Thank you, and now we have some space for some questions if you have.